There has never been such a radio silence as this one. After months of being unable to communicate with Voyager 2, NASA has finally re-established contact with the record-breaker interstellar spacecraft. Hey guys, hello and welcome to yet another amazing Informatica video. Before we begin and tell you about the final images of Voyager 2, what did it transmit back? Please subscribe to our channel and click the bell button to never miss a video from us. Please join us as we present NASA finally making contact with Voyager 2, which is 11 billion miles away from Earth. Number 6. The only man-made things to make it to interstellar. NASA launched Voyager 2 on August 20th, 1977 to research the outer planets and interstellar space beyond the Sun's heliosphere. It was launched 16 days before the twin Voyager 1 on a trajectory that took longer to approach gas giants Jupiter and Saturn but allowed for more contacts with ice giants Uranus and Neptune. It is still the only spacecraft to have visited both gas giants and both ice giant worlds. Voyager 2 was the fourth of 5 spacecrafts to reach solar escape velocity, allowing it to depart the solar system. NASA's Voyager 2 spacecraft is the second to enter interstellar space. The spacecraft joined its companion, Voyager 1, as the only human-made objects to penetrate the space between the stars on December 10, 2018. Voyager 2 completed its primary mission of visiting the Jovian system in 1979, Saturnian system in 1981, Uranium system in 1986, and Neptunian system in 1989. The spacecraft is presently on an extended mission to investigate interstellar space. It has been in operation for more than 44 years and has gone more than 11 billion miles from Earth. Voyager 2 continues to communicate with Earth via the NASA Deep Space Network station in Australia. Maintenance on the Deep Space Network disrupted outbound contact with the probe for 8 months in 2020. Number 5. Communication has been restored. The DSS-43 radio antenna, located in Canberra as part of NASA's Deep Space Network, is used to communicate with Voyager 2. The Deep Space Station 43 or DSS-43 was originally built as a 64-meter diameter antenna from 1969 to 1973. It was designed to communicate with spacecraft that were further away from the Earth as the signal became weaker. It was, however, expanded from a 64-meter diameter antenna to a 70-meter diameter antenna in 1987 to improve its capabilities for the Voyager 2 encounter with Neptune in 1989. It's the Southern Hemisphere's largest steerable parabolic antenna. The gigantic structure, weighing over 3,000 tons, revolves on a 0.17mm thick coating of oil. The perforated outer panels let rain and wind pass through. In March 2020, the DSS-43 was decommissioned as part of the routine maintenance. Because the facility required essential modifications, it had to be shut down for nearly 11 months while the work was performed. During this time, Voyager 2, which was almost 11.6 billion miles away from Earth and was moving farther away all the time, couldn't receive any transmissions from Earth, while scientists were still receiving its own broadcasts back to us. Finally, mission operators delivered a series of orders to NASA's Voyager 2 spacecraft for the first time after the service breakdown on October 29, 2020. Fortunately, Voyager 2 responded with a signal verifying that it had received the call and carried out the directives without incident. All communications with the probe were eventually restored by February 2021 after a massive antenna modification that took nearly a year to complete. Number 4. The improvements successful pings between radio antennas and spacecraft aren't generally newsworthy events, but because Voyager 2 is such a renowned and historic mission, it deserves extra attention, especially in situations like this, which involves a duration of one-way radio silence that's essentially unparalleled. According to NASA, DSS-43 had not been down for this long in over 30 years. The aging radio antenna that needed to be replaced had been in service for nearly 47 years and was the only one on the globe capable of broadcasting to Voyager 2. As part of the refurb, DSS-43 received 2 new antennas, upgraded heating and cooling equipment, power supply equipment, and other electronics to support the new transmitters as part of the refurb. These improvements will ensure the survival of a facility that is already famous, and the reason DSS-43 is the only dish in the world capable of reaching Voyager 2 isn't solely technological. Voyager 2's course drifted dramatically southward relative to the solar system's plane of planets as a result of the probe's flyby of Neptune's moon Triton in 1989, preventing Earthbound antennae in the northern hemisphere from reaching it. Number 3. Missions to other stars. Voyager 2 was described as working on an interstellar mission after its planetary mission was completed, which NASA is using to learn more about the solar system beyond the heliosphere. Voyager 2 is now transmitting scientific data at a rate of approximately 160 bits per second. The nova V1974 Cygni was discovered in the far ultraviolet by Voyager 2 in 1992. In July 1994, an attempt was made to observe the impact of comet Shoemaker-Levy 9 pieces on Jupiter. Because of the craft's position, it had a straight line of sight to the impact, and observations in the ultraviolet and radio spectra were made. On August 30, 2007, Voyager 2 went through the termination shock and entered the Helio sheath, passing approximately 1 billion miles closer to the Sun than Voyager 1. The Voyager's primary mission was to explore Jupiter and Saturn. The mission was extended after a series of discoveries there, including active volcanoes on Jupiter's moon, Io, and the complexities of Saturn's rings. Voyager 2 went on to investigate Uranus and Neptune, and it's still the only spacecraft to have done so. The present goal of the Voyager interstellar mission is to expand NASA's exploration of the solar system beyond the region of the outer planets to the outer limits of the Sun's sphere of influence and possibly beyond. The Voyager interstellar mission has the potential to collect useful interplanetary and possibly interstellar fields, particles, and wave sciences data until around 2025, when the spacecraft's ability to generate sufficient electric power for continued science instrument operation will be exhausted. Number 2. The Voyager 2 golden recordings are 2 phonograph records that were included on both Voyager spacecraft when they were launched in 1977. The records comprise sounds and visuals chosen to represent the diversity of life and culture on Earth, and they are intended for any intelligent extraterrestrial life forms that finds them. The records are like a time capsule. A committee convened by Cornell University's Carl Sagan chose the contents of the record for NASA. The record's content was chosen over the course of about a year. Sagan and his colleagues compiled 115 photos and a range of natural noises such as those produced by surf, wind, thunder, and animals such as bird and whale songs. They supplemented this with audio content to reflect humanity, spoken welcomes in 55 ancient and modern languages, including an English greeting from the former UN Secretary-General Kurt Waldheim and a greeting from Carl Sagan's 6-year-old son, Nick. Other human sounds include footsteps and Sagan's laughing, as well as the inspirational phrase "Per aspera ad astra" in Morse code, and musical selections from many cultures and times. A printed note from former US President Jimmy Carter is also included on the album. The ship will be encountered and the record will be played only if there are advanced spacefaring civilizations in interstellar space, Carl Sagan wrote, but the launch of this bottle into the cosmic ocean suggests something extremely promising about life on this planet. Number 1. Voyager 2's future. As the power from the RTG gradually decreases, several items of equipment on the spaceship have been shut off. The PPS was the first piece of science equipment to be turned off aboard Voyager 2 in 1991, saving 1.2 watts. Voyager 2 is scheduled to overtake Pioneer 10 in 2023, becoming the second farthest spacecraft from the Sun at a distance of around 12 billion miles. Voyager 2 is predicted to continue transmitting feeble radio signals until 2027, 50 years after launch. It is not heading towards any specific star, but will pass within 42,000 light-years of the star Ross 248. And if left alone for 296,000 years, Voyager 2 will pass by Sirius at a distance of 4.3 light-years. The fate of the Voyagers would likewise be determined by the terms of the galactic merger. Even if science data is unlikely to be collected after 2025, engineering data may be returned for several years longer. Depending on how much power the spacecraft still have to transmit a signal back to Earth, the 2 Voyager spacecrafts could remain in the Deep Space Network's range until around 2036. So what are your thoughts? What do you think of Voyager 2? And that's all we have for now. Thank you for stopping by to watch the video. If you enjoyed it, please like, share, and subscribe to our channel in the future for more entertaining and informative videos. We hope to see you again at the next one.